Section number 47 is, once again, solving systems of linear equations. But here we're going to use the substitution technique. These type of systems scream to use the substitution equation or method. And why is that true? Because one of these equations, namely the second one, is in the form y equals or x equals. This is another way of writing another way of writing y. Another way of writing y is this way. So I'm going to take this new way of writing y and plug it in right there in the first equation. Instead of saying y, or instead of writing y, I'm going to write 3x minus 2. So the first equation is 2x plus 3 times y. That's how I write y equals 5. Now the nice thing about this equation is, it's one equation and it only has one variable. I can solve it. First I'll distribute the positive 3. I'll get positive 9x minus 6 equals 5. So 11x's take away 6 is 5. This must be 11. Not because that says 11, but for real. 11 take away 6 is 5. If you want to add 6 to both sides to see that, fine. But 11x's, it's 11. 11 times this number is 11. 11 times 1 is 11. That is, x is 1. Now the nice thing about these type of problems is you already have an equation that says y equals. Y is equal to 3 times x, which we just learned is 1, minus 2. So y is 3 minus 2. Y is 1 as well. So the solution is x comma y. 1 comma 1. Solving for that second variable is a little bit easier because you have an equation that's already in the form, in this case, y equals. Let's try another one. Suppose you are given this line, 3x plus 2y is equal to 8, and you're told that x is equal to 4y minus 1. So this is another way of writing x. I'm going to put it in right there. So now that first equation will just have y's in it. 3 times x plus 2y is equal to 8. But this is just another way of writing x. When I see this, I can say x. 3x plus 2y equals 8. Yep, that's exactly the first line. Distributing gives us 12y minus 3 plus 2y is 8. Well, 12y plus 2y is 14y minus 3 is 8. Okay, so this must be 11. After all, if you add 3, you'll get 11. 11 minus 3 is 8. So 14y is 11. Okay. If 14y is equal to 11, then 11 divided by 14 is y. 11 divided by 14 is y. And now we have y. Then we can get x. X is equal to 4 times y minus 1. And 2 goes into this number 2 times, and that number 7 times. So you get 22 over 7 minus, I'm going to say the 1 is 7 over 7. For two reasons. One, it is equal to 1, and 2. I want the denominators to be the same in my subtraction column. So the bottom stays the same, and 22 minus 7 is 15. So the solution is x, which is 15 over 7, comma y, which was 11 over 14. What does it mean that's the solution? If you graph these two lines, first equation is a line and the second equation is the equation of a line. If you graph those two equations, they will intersect that point. The way it is. Let's try another one. And remember, not every two lines intersect in one place. Suppose you know that y is equal to 5 minus 2x, and that y plus 2x is equal to 5. So this is another way of writing y. You can plug it in right there. 5 minus 2x plus 2x equal to 5. Well, if you take away a number and you add it back, it's as if you didn't deal with that number at all. You have 5 equals 5. The lines, the two lines are the same. The two lines are the same. After all, in the first equation, if you bring the negative 2x to the other side, the y would stay on the other side, but the negative 2x will become plus 2x equals 5. This is exactly the same as the first equation. And you know what? It's the same as the second equation. They're the same two lines. So the solution is the two lines intersect. Keep in mind that's what we're looking for. Where do the two lines intersect? The two lines intersect everywhere on the line, and you give the equation of the line. Any one of those two equations will be fine. Y is equal to 5 minus 2x, or you could have said y plus 2x is equal to 5. Now, I just want to make a comment. I think I've already done it at least once. So maybe if I do it 50,000 times, you'll see it. If you do a long calculation or a short calculation and you get 7, and you meant to, and then you took away 5, but you didn't mean to. I don't know what you meant to do, but you didn't mean to take away 5. And of course, now your calculator is going to tell you 2. It's not going to tell you what that number was, and you forgot that number. By accident, you took away 5. And maybe it literally took you 5 minutes to get up to the 7. So you say, oh my, what a waste of 5 minutes. I have to start all over again. That's not true. You could undo taking away that 5. Just add it back. 7 minus 5 plus 5 is 7. So now your calculator is going to say 7 and go, oh yeah, I remember that was 7. How did I forget so quickly? And then you do what you mean to do. Maybe you meant to add 11. Okay, so now you have 7 plus 11. You don't have to clear out your calculator. Sometimes I think they should remove the clear button from a calculator. You may say, well, what if I did everything right and now the answer is 25 and I want to do a new problem? Well, take away 25. That'll bring you to 0 and start your new problem. What if you have y plus 3x is equal to 7 and y is negative 3x plus 4? So here's another way of writing y. Whenever it says y equals or x equals or z equals, substitution, right there, put in the alternative way of writing x. I meant to say y. Instead of y, you can write negative 3x plus 4. So we took care of y, we wrote y down. We better write down the rest. Plus 3x equals 7. Well, if you take away 3x and you add back 3x, well, that cancels out to 0. So you have positive 4 is equal to 7, which is, of course, nonsense. 4 doesn't equal 7, so there is no solution. That is, the lines do not, their two lines do not intersect. So whenever you get one number equals another number, if it's true, if it said 4 equals 4, then the lines intersect. They're the same two lines, and where do they intersect? Everywhere on the line. If you get nonsense, like 4 equals 7, the lines are parallel, and they do not intersect. Okay, that finishes the section entitled Solving System of Equations using the substitution technique.